frankly, some of us just don't think logically that way. And so we really don't want to rely on guessing. And sometimes guessing takes a very, very, very long time. So, and sometimes like on a test or quiz, we just don't have a very long time. So, I want to show you that I made it clear. I remember making it clear. There is nothing wrong with Chloe's strategy. If you can look at the scenario, 4, 5, 6, 7. If you can look at the scenario and guess, that is absolutely 100% fine. Okay? Okay, I can't remember. Why do we have jeans on today?
It's college.
Decision day. Okay.
What was the day after?
All right. So, the kids were guessing, Chloe guessed, other people guessed, everybody figured it out, it was great. If we want to do this like a real way, where's the end?
I was downstairs. In Dave's office.
You mean in Mr. Neeson's office?
Yes.
And did you write your pass?
No, he wasn't there.
Okay, why were you in his office if he wasn't there?
He has food. I had breakfast this morning.
Yes. Okay. Now, we are told in the directions that the sequence is arithmetic. And we have an arithmetic formula. All right? Now, what does A sub 1 stand for? The first term, which I don't know what it is, so I'm just going to call it A sub 1. I do not know what it is. What does D stand for? The amount that I add to get from term to term, so like plus D, plus D, plus D, right? And I don't know what that is either. Well, what do I know? Well, I know that this guy right here is the fourth term. They told me that. So the fourth term, 13, is the first term plus the common difference times 3. Now don't panic. A sub 4, n is 4. N is the number of terms. So 13 is the fourth term. The fourth term equals the first term plus d times 4 minus 1, which is 3. Well, what does 22 equal? Well, 22 is the seventh term, A sub 1 plus D times 6. Remember, A sub 7, N is 7. So the seventh term, which is 22, equals the first term plus the common difference. I do not know either one of those things, but I know n is 7 for this term, n is 7. That n and that n are the same number. So if you say a sub 7, then n is 7. Now, what's that? Isn't that like x's and y's? Isn't this like 2 equations, 2 unknowns here? So you could substitute or you could eliminate. I think I'll just multiply this bottom one by -1. So 9, what happens to these? Gone. And what do these add up to? -3d. So d is -3. Oh no, I'm sorry. +3. That was a -9. Now, how do I find the other thing I didn't know? Plug it in. So 13 equals a sub 1 plus 3 times 3. So a sub 1 equals 4. Now, look at what we did last time we were together. Is that what Chloe guessed? Did Chloe guess that D, the common difference, was 3? Did you write it down? I think she did.
Yeah.
And then we worked backwards. So it said -3, -3, -3, and came up with 4 as our first term. Now I know what some of you are thinking. Some of you are thinking, no way, I'm not doing this, I'm guessing. Guessing is fine. Guessing is fine if you can do it. All right, let's look at the next one. A sub 3 is 8, and a sub 7 is 36. Now again, it's arithmetic, and we are finding the first term and the 100th term. We found the 100th term last time we did this problem, so I'm going to do it again. All right. So I'm going to use my real math way of doing it, but if you're kind of guessing it out, just hang on to that, and let's see if we come up with the same answer. Here's my formula. I'm going to write an equation where n is 3. So a sub 3 equals a sub 1 plus d times 2. I am letting n be 3 because that's what the problem said. Now I'm going to let n be 7. So there's my formula. Just plugging in 3 for n and 7 for n. Can I eliminate in this one?
Yeah.
Yeah, these are always really easy to eliminate in. And you have a calculator for the whole mess always. -28 equals 4d. Keep doing that. I got 7 for d. So what's my first term? If d is 7, then 8 equals a sub 1 plus 14, and a sub 1 equals -6. Did you get that? Anybody else get that? I'm having trouble with my arithmetic today. So the question said, what is the first term? There it is. First term is a sub 1. So right there's the first term. Now, what will the 100th term be? That's a sub 100, 100th term. Well, what's it going to be? According to our formula, the 100th term will be, what's our first term? -6. What's our common difference? What's our D? 7. And if we're finding the 100th term, then n is 100. So n minus 1 is 99. And I'll just type that in on my calculator. I got 687. guys get 687 for that, typing it in? Okay. All right, here we go. One more. Oop, I erased my formula. We're using this formula for all of these problems. All right, so the sixth term is going to equal a sub 1, the first term, plus d times what? If I'm doing the sixth term, then what's this going to be? 5, very good. And then the ninth term is the first term plus d times, okay, what's going to go here if I'm doing the ninth term? 8. Now, let's just go ahead and cancel out these guys. So, I'm just doing regular elimination, so I multiplied this by a negative, that way that will cancel out. So 9 equals negative 3d. I got negative 3 this time. Did I do that right? Try to stay awake. What do I do now? Plug it in. So one of these, I'll just use the top one. So negative 1 equals a sub 1 plus negative 3 times 5. Oh gosh, I got 14. What do you think? Is that okay? You got 14? All right. Now I want the 100th term, because the question asks that. So using my formula, the 100th term will be 14 minus 3 times 99. Why 14? Because that's my first term. Y minus 3, because that's my D. And Y 99, because if I'm finding the 100th term, N is 100, so 100 minus 1. So that one, we have 5, get it right. Negative 283. Okay, that's a test question. So if you're still struggling with that a little bit, I know it's a little tricky, but the good news is that formula, the whole thing uses that formula. You don't need anything else.
Are you given the formula or is it by the
You're going to have to memorize it. After you do your homework, if you've started or anything, after you do a few problems, you pretty much have it memorized. Okay. Now, actually, Matthew, I'm gonna change my mind on that. I think I'm gonna give you the formulas because we got about 4 or 5 more to go. But I'm not gonna tell you what they're for. So you're gonna have to know that formula is for arithmetic sequences.
Gotcha.
All right. I hope I remember I said that. All right. For the follow, now I'm ready for number 5. for the following geometric sequences. All right, refresh my memory. What is the difference between arithmetic, which is what we were just doing, and geometric? Yeah, in the ones we just did, we were going down the line by adding something. Now we're going down the line by multiplying. And the number that we multiply by is called the common ratio. We used D for arithmetic because that's called the common difference. So in this case, the ratio is 2. Can you see that? All right. So the ratio is 2. Already answered that question. A sub 1, already answered that question. It's right there. What does A sub 1 stand for? First term. And the first term is 3. Easy. Now we have to find the 10th term. Okay? Now, let's take a look at this for a minute and see if we can figure out what's going on. The first term was 3. The second term was 3 times 2. The third term was 3 times 2 times another 2. 12. And then the fourth term was 3 times 2 times 2 times another 2. So we just keep adding a 2 on or multiplying by an additional 2. Well, do you see a pattern here? The first term was 3 and no 2's. But the second term was 3 times 1 2. What was the third term? 3 times 2 2's. And the fourth term was 3 times 3 2's. Do you see a relationship between the term number and the number of 2's we have? What is it? What's that relationship? What's the relationship between 4 and 3? 3 and 2.
They're going down and going up. It looks like the same last time.
Whatever term number you're on, you have 1 less 2 than that. So we could guess, we don't have it up here, but we could guess that the 5th term will be 3 times 2 to the 4th. So what will the 10th term be? 3 times 2 to the 9th? Does that make sense to you? Which is going to be a large number. 3 times 2, whoops, to the 9th. 1,536. Yeah, Kai?
So how would you know to keep the pairs together? So like you see how it goes like 3 times 2 equals 3 times 2. But how would you know to keep 3 times 2 times 2 equals 3 times 2 in the next one?
Well, you mean like this?
Yes.
Well, this is what I'm doing each time. I'm multiplying by an additional 2.
So you just keep adding it.
I just keep sticking a 2 on there. But at some point, I get tired of writing all those 2's, so I'm going to use exponents. Because if I wrote this out, think about what that would look like. 3 times 2, 2, 2, 2. I don't want to do that. So it's 2 to the 9. Now, in general then, because I really don't even want to do this next time. In general, I found this term, or we found this term, by taking 3 times 2 to a power. Now, where did the 3 come from? What was the significance of the 3? It was the first term. I'm trying to build a formula here. So I took my first term, and then I multiplied it by 2. Well, what was the significance of the 2 in this problem? That's my ratio. And then, if I am finding the nth term, what is my exponent? Not n, they don't match. This wasn't a 10.
N minus 1.
N minus 1. There is your formula for a geometric sequence. You know how we had this formula for arithmetic? Now we have a formula for geometric. Obviously you need a different formula because you're doing a different thing. You're multiplying, not adding like we were with our arithmetic. Okay, well that was easy enough. Let's look at the next one. Let's see if we can use our new formula for the next one. Okay, so problem number 2, or B, problem B, says what's R? Well, what are we multiplying by, guys? 1/8. Remember with sequences, we either add or we multiply. So sometimes we have to add a negative, and sometimes we have to multiply by a fraction to get the division part of it. All right, what's a sub 1? 8. This is a sub 1. A sub 1 stands for first term. And again, we want the 10th term, so what does our new formula tell us? The 10th term will be 8 times 1/8 to the 9th. All right, let's type that in, make sure we all can do that. If you type it the way I wrote it, it'll be perfect. Remember, this is just 1 divided by 8. So 8 parentheses, 1 divided by 8 parentheses, to the 9. Oh, I got scientific notation, did you? Geometric sequences get really big or really small really fast. So I got 5.96 times 10 to the negative 8. That's really small, you guys. And that's only the 10th term. I'm going to talk a little bit more about that in a little bit. All right, would you try C? See how far you can get with problem C. On a test or quiz, you're going to have to be able to figure out if it's arithmetic or geometric. Here I tell you, in the directions it says it's geometric. Could you figure out this was geometric?
Yes.
How?
Like seeing if it was multiplication.
We're multiplying by what? By 3? Negative 3. Aren't we multiplying by negative 3?
Yeah.
Isn't the sign going back and forth? So R is negative 3. If you are multiplying, then you know it's geometric, and you know you'll be using this formula. Do we know a sub 1?
Yep.
Of course we do. They told us it's negative 6. And now we need the 10th term, so tell me how you set that up. Negative 6, parentheses, negative 3 to the 9. And if you type it in just like that, you are going to get the right answer. Oop, I got a great big number, 118098. Anybody else get that? All right, we have one more thing to do today. We're going to finish 9-4 notes today. We have one more thing to do. And then we're gonna practice some other stuff a little bit. But here we go. We're gonna talk about limits. We're in a pre-calculus class. Limits are a big part of calculus, so we need to have some kind of understanding of limits, even though the problems can get really hard. We're going to do really hard ones, but we're going to just get the basics here. So what it means to be a limit is, when I have a sequence of numbers, I can do one of two things. I can either keep marching, and run into a wall, called the limit, or I can keep marching forever and forever and forever. So if I can either, right here, then we're past this. Or it keeps going and going to Loretto Hall and beyond. So I want you to look at this set of numbers and tell me what you think. Does this set of numbers appear to be heading somewhere, or is it just going? It's just going. Aren't these numbers just going to keep getting bigger and bigger and bigger? And in fact, this is a special set of numbers that I had you look at the other day. These are the squares. 1 squared, 2 squared, 3 squared. So it's just going to keep going. You're going to have 10 squared, 100 squared, a zillion squared. This has no limit. And when it has no limit, we use the word divergent. To diverge means to split off, right? To go out. And that's what this does. This is divergent, no limit. Now, I want you to look at the next set. 1/3, 1/9, 1/27. Think about this set. What do you think about these numbers? What? Well, so definitely it's geometric. I'm multiplying by 1/3. So 1/3 times 1/3 is 1/9 times another 1/3 is 1/27. It's definitely geometric. So if I said to you, let's find the 10th term, you could do it using our new formula, but this is a different question. Is this sequence doing the same thing that one did? Is it just getting bigger and bigger and bigger and bigger and bigger? Or is it heading, is there going to be a wall that it's going to hit that it's not going to be able to go past? Think of it on the number line. Here's 0 and here's 1. Okay, so here's, oh, actually, no. Here's 1/3, right? The first one. And then here's 1/9. And here's 1/27. What's happening to these terms? They're getting smaller. Now, getting smaller, Creighton, could mean getting smaller clear out here in negative a million zillion land. Is that what's happening to these? Are these ever going to be negative? No. They're getting smaller, but they're never going to be negative. So what are they getting closer to? 0. The limit of this sequence is 0. No matter what, kids, can you see how this is a wall? These terms are going to keep going closer and closer, but they're never going to go past 0, because if they went past 0, they'd be negative. And these numbers are never going to get negative, because Madeline said, I'm multiplying by 1/3. And as long as I keep multiplying by 1/3, I'm going to stay positive, right? So the limit is 0. All right, how about the next one? -2, 4, -8, 16, -32. What's happening to that one? Okay, so it's geometric. I'm multiplying by -2. So the terms are kind of flipping back and forth, positive to negative, right? But if you think about that number line again, here's 0, here's -2, here's 4, here's -8. Every time they flip, they're flipping back and forth, but every time they flip, what are they doing? Going farther out? So this one is also divergent. If you are going to have a limit, then that means you're getting closer to something. So this one had a limit because as you kept going, you were getting closer and closer to 0. These are flipping back and forth, but every time they flip, they go farther out. So they're not getting closer to anything, they're diverging, just like this one did. Only it was just going one direction. Now, all the rest of the problems on the page don't look like this. All the rest of the problems on the page are written like with a formula. Now, when I say this is a sequence of numbers, if you put in 1, you don't need to do this, but just watch so you see the connection. If I put in 1, I get 1/2. If I put in 2, I get 2/3. If I put in 3, I get 3/4, and so on. That is a series of numbers, a sequence of numbers. I want you to dig back in your brain, a long time ago. Actually, wasn't that long ago because we did it again in chapter 7. If I said to you, what is the horizontal asymptote of this fraction? So if we were graphing x over x plus 1, and I said, what's the horizontal asymptote? What would you say? How do we find horizontal asymptotes? Oh my. Do we compare the highest powers of the variable?
Yeah.
So when we have x over x, that's 1. The limit of this thing, as n approaches infinity, is 1. So let me write that again down here because I got underneath the board there. The way we write this is the limit as n approaches infinity. So LIM stands for limit. Underneath the LIM, I write n approaches, that's an arrow, infinity. And then I write my problem, and then I say what it is. And you find the limit of things like this the same way you found the horizontal asymptote. The horizontal asymptote is a limit. So you compare the highest powers of the variable, n over n. If you look at the numbers I'm getting when I was writing these out, can you tell these are getting bigger?
Yeah.
I mean, decimally, that's 0.5, 0.6, 0.75, 0.8, 0.83. These are getting bigger, but the numerator is always going to be smaller than the denominator, so you're never going to go past 1, so the limit's 1. And that's the way you're going to write it, okay? So, what about E, letter E? What do you think the limit is there? You guys, how can you stare at me with open eyes and not answer this question? Yes, thank you. Right there it is, right there. So the limit as n approaches infinity of 2n minus 8 over 3n plus 6 is 2/3. Notice that when I'm doing the limit, just like when I did the horizontal asymptote, the only thing that matters is the n part. I'm not concerned about these numbers because I'm letting n get really big, like millions. What do you think about f? The limit as n approaches infinity of 4n squared plus 6n minus 3 over 5n squared plus n plus 1. What do you think that limit is? 4/5. Is that 4/3 or 4/5? 4/5. The highest power of the variable is all you look at. So all you look at is the n squareds. That is exactly what we did with horizontal asymptotes, guys. I hope it looks somewhat familiar. Now, what about G? Something is a little different about G. What do you notice about it? Well, the powers don't match, right?
Yeah.
So then your answer depends totally on where the big one is. So the big one's on the bottom, which means that on top, I have a 0 n squared, I have no n squareds on the top. So when I box them in, I have 0 over 5, which is 0. So the limit of this is 0. H is exactly the opposite. Now the big one is on top. So you have no n squareds on the bottom. What happens when you do that? Undefined, which means no limit, which means divergent. If it's undefined, there is no answer. And if there's no answer, that means there's no limit, because that's the answer you're trying to find. And the definition of no limit, or the word we use for no limit, is divergent. All right, so there are 3 basic limit rules we're learning today. And one of them we just did. And I say learning, we already knew this. We already knew this. If your expression is n's over n's, you just compare the highest powers, okay? Whatever the highest powers are, that's what you compare. Now that's a little different than problems I and J. Do you see the difference? You do not have n's over n's. You have things to the nth. Things to a power. So first of all, we recognize the difference between this problem and this problem. Okay? There's a difference. Now I want you to take your calculator out. And I want you to do 2/3 to the 20th, and then I want you to do 5/4 to the 20th. Now I'm just making up the 20. I could use any number in the whole wide world. 20 just popped into my head. So in parentheses, 2 divided by 3 to the 20th power. Do you get a big number or a little number? How do we know it's little? It's scientific notation times 10 to the -4th, right? All right, now what about parentheses 5/4 to the 20th? You get another little tiny number? It's not huge, but it's bigger, right? I mean, it's a big number. The difference is, if you are taking a number less than 1 to a power, that means you're multiplying 2/3 times 2/3 times 2/3 times 2/3, da 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 da. That just keeps getting smaller. Think about it. If you multiply something by 2/3, then it's smaller. But what if you multiply something by 5/4? Then it gets bigger. So if your number that you're raising to the power, like the 2/3 here, if it's less than 1, your limit is always going to be 0. Because eventually this number is going to get really, really, really small. If the number you're raising to the power is bigger than 1, anything bigger than 1, then it's divergent, no limit. Okay, but wait a minute, Mrs. Ford, what about that exponent? Doesn't matter. Doesn't matter what the exponent is. I could make that n minus 100, n plus 100. I could do whatever I wanted with that exponent. That doesn't matter. What matters is the size of the base, the size of that number right there in the parentheses. If that's more than 1, divergent, automatic. If it's less than 1, the limit is 0, automatic. Okay? Tell me about K. It looks different. Tell me about it. What's 1.5? Isn't that 3 over 2? Isn't that bigger than 1? So that's divergent. And what about, what is it, JKL? What about L? 0. 0.8 is 0. Now I said there were 3 limit rules we're using. Let's review. We've only used 2 so far. I gotta give you the 3rd one. I have to add it in because I have it on there. So the first rule is, if the problem looks like this, if you have n's over n's, then you compare the highest power. That's how you do it, just like your horizontal asymptotes. If your problems are something to a power, so a number to a power, we don't care what the power is, it could be anything, we don't care. If this number is less than 1, 0 is your limit. If this number is more than 1, divergent, there is no limit. Okay, and then the other one that I want you just to be familiar with is if you have the limit of a constant. So if you have a problem like the limit of 10 or the limit of negative 13, if you have the limit of just a number, notice no n's, just the number. Any guess what that limit is? The number. So the limit of a constant is the constant. You're thinking that's kind of dumb, Mrs. Ford. Trust me, you'll use that concept. The limit of a constant is the constant. So 3 kinds of limit problems you need to be ready to address. Anybody have any question about that? All right, let's get out our homework real quick, our homework packet. And look at that real quick here. Oh, wait a second. This is period D. And I have play people in here. And I always make play cookies once a year since this is musical. So here's a cookie for you to celebrate our great thespians. So have one, pass them around, please. Just take one. I have other classes. All right, we're looking at our homework. Homework 9.4. Down at the bottom it says evaluate. I'm not going to do the rest of this homework with you, but let's do the limits at the bottom to make sure everybody's got this sorted out. Okay, so problem A. Problem A. Be careful, I got tricky. What is the limit of problem 4A?
3 negative 4.
So negative 3/4. Because even though I wrote the problem backwards in the bottom, it's always n over n, right? So the answer to 4A is -3/4. Would you look at that and make sure that makes sense to you? You okay with that? -3/4. Good. All right, how about B? 0. And why is it 0? Because the number I am raising to the power is less than 1. That's the key. And what about C? There is no limit, because in problem C, we have 2n squareds on the top and no n squareds on the bottom. Now notice, I didn't even write the rest of the problem because none of it matters. The only thing that matters is the n squared. Can we have 2/0? No. So C is divergent. Divergent.
Yes, right now.
You can write no limit.